Hello, and welcome to MRI Uncensored. Today, we're going to talk about hydrogen. Why hydrogen? Well, hydrogen's atomic number is 1. It's the lightest element out there. It's colorless, odorless, tasteless, and it's the most abundant element out there, 3 times more abundant than helium. It has the ability to form covalent bonds with nonmetallic elements. This leads to the formation of water and other organic compounds. It also forms ionic bonds. Now, hydrogen can be found in 3 different forms. The first one we'll talk about is called a protium. This contains 1 proton in hydrogen's nucleus and 1 orbiting electron. The next one is deuterium. This contains 1 proton and 1 neutron in the nucleus and 1 orbiting electron. Finally, tritium. It contains 1 proton in its nucleus, 2 neutrons in the nucleus, and 1 orbiting electron. A protium is the most abundant form of hydrogen out there, and it's considered an isotope. Hydrogen is derived from the Greek word maker of water, and it's very fitting considering we as humans are made up of about 70% water. Its inherent energy is based on its environment in an external magnetic field. Hydrogen in the form of a protium is what we target in MRI. It spins on its axis, and any particle that spins on its axis produces angular momentum. This describes the degree of precession or wobbling that hydrogen demonstrates. Now, this is influenced by a magnetic field. So when we place a patient in a static magnetic field, we can see that the precessional frequency of hydrogen is relative to the magnetic field that we place our patient in. There are 3 behaviors of hydrogen. Now, the first one is the spin that we talked about, and that produces angular momentum. Hydrogen's angular momentum is equal to its mass, velocity, and radius. Not only does the spin produce a precessional frequency of hydrogen, which is actually a pseudo frequency, it also gives rise to a magnetic field. We call it a magnetic moment. Everything in nature wants to return back to its weakest energy state, and hydrogen is no different. When we excite hydrogen to a higher energy state using an RF pulse, we'll see that the energy of hydrogen increases due to resonance. When we turn that RF pulse off, hydrogen relax back to their starting point. This starting point is based on the environment or magnetic field that hydrogen is sitting in. There are different isotopes that we can use as well instead of hydrogen in MRI. Fluorine-19 is one of them, phosphate-1, carbon-13, nitrogen-15, and oxygen-17. This concludes the presentation on hydrogen. Thank you for watching. If you like what you saw, please hit the like button and subscribe. If we get enough subscribers, we'll keep making more of these videos. Thank you. See you next time.